going to have Yingying Zheng and Li Tao from Circle to talk about programmable wallets. So now let's welcome to stage Yingying and Li.
Thank you. Okay, good afternoon, everyone. So my name is Yingying from Circle's Web3 Services team. So today I'm super excited to be here together with my colleague Li Tao. We're going to introduce our latest Circle's Web3 product called Programmable Wallets. And today we have a pretty packed agenda. So we're going to talk about why Circle want to build a Web3 wallet, and also what kind of features it will provide. And we're also going to do a demo. So we originally want to do a live demo here because we think it's cool, but we're worried about the internet, which also doesn't work right now. So we actually recorded everything for today. But I also didn't anticipate this is such a large screen, so I added some very funny magnifier effect in the video. So you will see it's quite large. Okay, so this demo will also include how we are able to create a Web3 wallet and make a gasless transactions and verify everything working on chain within 5 minutes. So this is pretty cool. So we're going to demo this gasless solution that we recently introduced to programmable wallets first time in the public. Okay, so let's get started. So Circle, our company, has this one mission to once make USDC available to everyone in the world. Right? So while working with more than 4,000 businesses that use USDC, we actually found out there are a very wide range of use cases that they're building, like NFT marketplace, gaming, DeFi, e-commerce, or even just like Web 2 businesses that are trying to extend to Web 3 domain. So I'm not going to go through all these details that I listed on the slide. Basically, we know that beyond the USDC, so what our customers need is a secure Web3 wallet that can be tailored for seamless Web 2 experiences. So Circle, if we are able to create or provide those Web3 wallet solutions to our customers, right? So then we can also boost our USDC adoptions as well as circulations, which we find this is high synergy with our missions. But then when we look into this domain, actually there's not that many great end-to-end wallet solutions out there, especially if we look at this seamless experience. So I can give you a real-life example. Let's say if there's a deal. Say you get $20 for 10. Who wants the deal? So I personally want it. I think it's a good deal. At least I will try it out, right? So this is actually a real experiment that happens recently in West Auckland Farmers Market. So the Oak community, by the way, Oak, O-A-K, is a community currency for Auckland. So this Oak community basically gave out this 20 USDC to the users and to let them to spend in the farmers market, as long as they pay like $10 in cash or Venmo. Right? So it's a good initiative. It's also a good deal. But actually, there's very few people that actually went through the entire flow or completed at least one transactions at the end. So why? Let's take a look at the user experience, right? For the user experience on the customer, right? So what they need to do, they need to first pay $10 to a Venmo account that's owned by this community, and they need to download or set up a Rainbow wallet. So if you ever use MetaMask or Rainbow wallet or basically any self-custody wallet, you know that they will give you a recovery phrase, right? And you need to figure out how to store it securely. And you need to figure out some native token. You need to get some native token in this wallet to be able to pay the gas. In this case, I believe this community basically send those Matic to each customer's addresses, and then basically to be able to initiate those transactions. And they will also receive the 20 USDCs to start using. And at last, if you still have some of the remaining USDCs, basically you will need to figure out a way to off-ramp from that Rainbow wallet. So this is the merchant experience, right? So as a merchant, I need to first check out on Square. I need to receive transactions on Rainbow. Sorry, I think the numbers are wrong when we converted it to PTBTX. So we need to receive transactions on Rainbow. Again, like if you don't have Rainbow account, right? So, or a Rainbow wallet, so you will have to set it up. You will also need to worry about these recovery phrases as well. And then you need to off-ramp with Coinbase because Rainbow wallet doesn't support cash out, right? So you need to connect your Rainbow wallet with Coinbase and then convert your USDC into USD. And at the end, you will reconcile the transactions. So you can see there are multiple steps and multiple apps that is involved on each side. And some of those steps are not intuitive or trivial to especially like first-time Web3 users. So how do we make this Web3 user experience frictionless for users and blockchain development effortless for developers? So you can see right now we are focusing on both user experience and the developer experience. So if we take a closer look at the current pain point of end users, right? So as I mentioned, the onboarding experience is important to all the applications. However, onboarding to a Web3 wallet is hard because the user will be educated to know, oh, I'm fully responsible to my private key management, and I need to figure out a way to securely place the mnemonic phrase somewhere, right? So they need to understand all these concepts. And when connecting the wallets, there are external, browser extensions that might be needed. Additional logins might be needed. So it adds a lot of frictions to this user flow. And once the user is finally able to make a transaction, they were told, oh, you don't have native token. What is native token? What is gas? So they still need to figure this out, right? And again, like account recovery, this goes back to this mnemonic phrases management. So they will need to first find a safe spot to save it, but at the same time, they will need to be able to retrieve it anytime they want. So this is tricky. And I also want to focus more on the developer experience because this is related to everyone in this room. We all know that it's not trivial for private key security and management, right? So as a developer, we will need to balance the security of users' assets versus the ease of use and the complexity of the system, maybe. You will also need to figure out what type of wallets that you're going to provide to the customer, like custodial versus non-custodial solutions. For example, like if you want to provide a self-custody wallet to the user, right? Again, it goes back to the add all these burdens on the user that they are solely responsible for the key securities. At the same time, some of the use cases that might not be suitable for self-custody wallets. For example, like gaming, right? So you want this entire experience to be super smooth when interacting with the crypto wallets, so that you don't want, during the game, there are user confirmation pop-ups all the time. But at the same time, the good thing is the non-custodial wallet is, decentralized because this domain is talking about decentralization. So this is also important, right? If you choose to provide a custodial solutions to the user, then that means that now you as a developer or a company are fully responsible and liable to this, key management. At the same time, you might not be having this right license to hold the assets or the token for the user, or you don't even want to deal with those liabilities to be a custodian. And then at the end, even you figure out which type of wallet you want to provide, you still need to have enough, as a developer, you need to have enough experience, expertise on blockchain integrations, node management, figuring out EOA versus smart contract account. Noam from Alchemy had a great talk this morning and talk about smart contract account and account abstraction. But still, you need to have all these knowledges. And you will need to keep up to date with all these emerging protocols, right? So NFTs, new ERC standard, and also new chains. Again, as a developer, you will need to have a good tooling to be able to monitor, identify, and troubleshoot any on-chain activities in a programmable way, right? Because you want to be able to scale. So with all these pain points, right? So how programmable wallet solve the pain? First of all, so programmable wallet provides a MPC wallet, so that the developers can embed secure wallets into their application seamlessly. Just going back to the example of farmers market, right? So for the customer, they might not need to download any additional wallets application or any additional applications. They can just use their existing applications that they are familiar with, and they can access to the crypto world without even noticing it, as long as this application has embedded Web3 wallets, right? And the good thing for embedded wallets for a customer is that, a developer is that they can continue to leverage their existing user base, existing architecture, existing platform, ecosystem, just with some add-on capability of Web3 wallets. And also the MPC solution helps to balance the user experience as well as the security of the wallet. Also, the way that we build our API is chain agnostic. We will show that in the demo shortly, that you don't need to worry about any difference in terms of implementation details between the chains. Basically, you just need to specify one chain or multiple chains in your request, and it should just work the same. We also provide user control wallet versus developer control wallet. So the key distinction between the two wallets basically is which party has the ability to access the private key of the wallet. So in this way, you basically are able to fit different use cases without changing too much code. Yeah, and then we have this called developer console. We will also demo that shortly. That you're able to use that one-stop shop developer console to monitor and troubleshoot your both off-chain and on-chain activities. And that developer console provides different environments like testnet, mainnet. You should be able to verify everything that's working on testnet, and then with one click, you're basically launched onto mainnet. Last but not least, gas station, our favorite topic. Gas abstraction basically allows the developer to abstract the gas fee from user, and it also allows Circle to abstract the gas fee from developers. So we will show that as well. Okay, so I'm gonna hand it over to Litao for some technical details and drive the demo. Okay.
Hello. All right. Good afternoon, everyone. I'm Lee. I'm an engineering lead on the Web3 service team at Circle. And today, I'm happy to show you how Programmable Wallet works from a more technical perspective. All right. Starting from the high level, Programmable Wallet is a set of REST APIs, right? And we use these REST APIs to provide you a one-stop shop experience for developers to build on. And to start off, you as a developer has the control, the flexibility to choose who controls your wallet. Right? On the left side, you have developer controlled wallets. On the right side, you have user controlled wallet. If you choose developer controlled wallet, you basically yourself has the full control of the wallet. And all you have to do is make REST API calls to our APIs. And this model is best suited for making your user experience more similar to Web 2, right? Where your user have to worry about very little. On the right side, for user-controlled wallet, you can give your user the full control of their wallet. They can take care of their own actions on the wallet. And all you have to do is pretty much just embed our client-side SDK into your system. Okay, so how do we secure your wallet at Circle? We at Circle use MPC technology to secure the wallets. Quick recap on MPC. First, MPC basically tries to do is, instead of having a single private key, you now have a set of it divides the private key into a set of key shares, and the key share are distributed among participants, and those key shares need to come together to perform the signing. There are several important, I think, benefits of using MPC, right? First one is the complete key share is never revealed during the whole process, right? Next one will be those key shares can be distributed independently towards participants, so that no participant, like no single participant, can, let's say, malintent or steal the keys. Third one, MPC also works completely offline, right? Instead of on-chain, you now have a completely off-chain algorithm that enhance your privacy, so you don't have to put your data on-chain. So last but not least, MPC have the benefit of actually being blockchain agnostic, right? It is not subject to the blockchain implementation, and it works one layer deeper, it works directly with the cryptographic keys. So currently, I think there's much more to talk about MPC, but we'll not deep dive into it. We have a packed schedule today, and we at Circle believes MPC is probably currently the best technology available to secure cryptographic wallets. All right, so what good of a wallet if you cannot easily access it, transact with it, and interact with smart contract with it, right? And here, this simple graph shows you basically a simplified version of how we internally model the transactions lifecycle. What we provide is a set of unified APIs. You can basically perform transfer transactions, contract execution transactions, and we support multiple ERC token standard. So ERC 20, 1155, 721, you name it, right? And highlight in the yellow circle is the key actions that you can take during the transaction's lifecycle, right? New transaction, I think that is needless to say. And we have also have the feature of cancel and acceleration. So imagine like now you have a user, right? The user order coffee, right? And he doesn't want to wait for like payment confirmation. He wants to speed things up. Just call our acceleration API on the transaction. And on the other example, if you have user who mistakenly submit a transaction or let's say click a button on your app, now he or she wants to take it back, you can simply call our cancellation API for that transaction. Right? One of the biggest and pinpoint of today's Web3 experience, I think Yingying also mentioned that in her slides, is that user has to first source some gas before he even trying to do anything like with his wallet. If you think about it, if a user trying to buy an NFT, right, he may have to first get some Ethereum, and that doesn't make much sense. So one way to solve that, one way to abstract the gas concept from user is to use through account abstraction, particularly ERC 4337. Right? I'm pretty sure everyone here like already heard about ERC 4337 and account abstraction. Noam gave a terrific speech this morning, and I will not go into too much details, but here's a quick recap. Right? What it does is that instead of having a EOA account, or like you have EOA account today, you're now having a smart contract as your wallet. Right? And instead of submitting your regular transactions on chain, you are submitting a user operations, which is sort of like a meta transaction. And this user operations has a bunch of data elements. For example, it has like signature, it has call data, call gas limit, like senders, nonce. But most importantly, I think we're going to talk about one field, which is the pin master and data field. Right? And that particularly on the user operation enables us to pay gas in a number of different ways. For example, you as a developer can now pay gas for your user, right? You sponsor that gas for your user. All right, cool. So I can say 1,000 words, but it wouldn't be more powerful than a demo. So here I'm honored to show you a Programmable Wallet demo with our sneak peek for the smart contract account feature that we're about to launch. Yep. Right, demo please. Hello everyone, this is Lee, Tech Lead for Programmable Wallets at Circle. Today I'm going to show you how to create your first user-controlled wallet and make your first gasless transaction within minutes using our API and SDK. First, you need to sign up at login.circle.com. This is our Web3 developer console, and you need to apply for API key. Here, we'll simply apply API key through the create a key, and we'll call this API key demo key. Keep this API key, and this API key will be used to authenticate all your API calls. Next, we're going to make some API calls. First, create a new user by calling the post users APIs. Save this user ID so you can later reference it in your system. Next step, we want to generate a user JWT token. The user JWT token will be generated by calling user/tokens API, and both of the user token and the encryption key will be used together for user authentication purpose. Save and paste both of them into your sample app. Next, we're going to initialize the user by calling the post/user/initialize API. Here under the blockchains, you can specify a list of blockchains that you want to create the wallets on. By calling this API, it will return a challenge ID. Copy this challenge ID and paste it into your sample app. Click execute, and now you can let your user take over to enter their pins. Right, here to save some time, we will skip the recovery flow setup on the sample app. Next, we're going to create another wallet on Polygon testnet by calling the post/user/wallets API. Here we copy the challenge ID, paste into our sample app. Okay, now let's go send our first transactions. Let's quickly set up a webhook. Here we'll use webhook.site to do a quick demonstration. Click New and click Create. Let's copy the URL, navigate to Dev Console. Under the webhook section, click Add a webhook. Before we make our first transactions, let's quickly verify our wallet balance. Here you can see this is the address of the wallet we just created. It has 0 native token on the testnet and 10 random ERC20 tokens. Let's cross it, verify it on the block explorer. Here you can see this is the address that we just copied, and you can see that it has 0 balance on Matic and 10 Matic ERC20 tokens. Now let's jump into the API calls. Here we have filled in all the required parameters to make the first transaction. The transaction API is post/user/transactions transfer. And we click transfer. We grab the challenge ID and we navigate to the user. Now the transaction is initiated. Let's wait a moment and see what happens. Here you can see the balance has already changed. It has reduced 5 Matic tokens without spending any amount of native token as gas. Let's cross-verify it in our Dev Console and Block Explorer. In the Dev Console, now we can see we have made our first outbound transfer with 5 ERC20 tokens without spending any gas from this wallet. Now let's cross-check it on the Block Explorer. Here, the address has properly spent 5 ERC20 tokens, and the balance of native token remains. Let's also cross-verify our webhooks. Now we can see starting from the very first webhook, we have received a hello world test webhook. And at the end of the day, we have received a state of complete for our outbound transactions. All right, cool. I think that's it. Let's go back to the slides. So hope every one of you like it, and hopefully this is easy enough. But we'll continue improving on it, of course. All right, cool. Now that you have seen how the API works in action, right? And here is an overview of how the system works behind the scene. So essentially, Programmable Wallet is a set of a suite of microservices, right? It's a classic microservice architecture, and each of them take a different responsibility. Each of them provides some level of abstraction for Web3 concepts. For example, your external request as a user that we just sent in the demo flows from the left side, right, and into the Programmable Wallet, pass through our API gateways, and it flows through all the section of the subsystem. Finally, it reaches back to you in the form of either a direct HTTP response or a webhook callback. So let's take a look at the specific system here, right? For example, the chain integration. On the bottom right side, here we have a suite of microservices that is pretty much doing abstraction for blockchain interactions, right? They will build transactions, they will handle node management, they will listen to blockchain events, keeping our system and the blockchain in sync, and they will broadcast transactions, right? So it's important. And on the right top most side, you have paymasters, right? That is what makes the gasless transaction you saw available. It basically takes off everything that is related with sponsoring a wallet's transaction, right? And we also have modules that take care of smart contracts. We have smart contract templates. We have places that you can switch authorization models, like authentication models, and of course, the module that manages keys, right? So given all this, right, as a result, you as a developer, whether you have one user, all right, or you have 10 million users, right, you can scale effortlessly. And you can be blockchain agnostic, which means you don't have to worry about blockchain's specific consensus protocols. There are different cryptographic algorithms. You deploy on multiple blockchain by only building once, right? And similar for the user authentication and the wallet securing user's wallet, all of those are taken care of by the Programmable Wallets itself. So you as a developer can focus only on building the user experience in your application. All right, I think that is pretty much it. And I encourage everyone here, highly encourage you to just scan the QR code, sign up, apply API key, and play around, right? We're looking forward to see what you can build, and we appreciate any feedbacks you have. Also to remember, Programmable Wallet is the first service that is going to launch, that has already been launched, and we have a suite of new launches coming for our Web3 services. All right, thank you, and please reach out to me and Yingying if you have any further questions. I don't think we have more time here, but we can answer all the questions in person. Thanks, everyone.